Yay. Hello? No. Hold on. Okay, so everybody hear me? All right. So I am not staff, so I know my shirt looks a lot like the staffer shirts. Don't. If you have a problem, don't come see me because I won't be able to help you. So as mentioned, my name is Peron. And I'm going to be talking to you about some of the testing and kind of DevOps related work we're doing around our WAF at Fastly. So just quickly, I'll just kind of go through. So I'll introduce myself. I'm not really going to talk about myself. I'll mainly focus, kind of like introduce Fastly and what we do. Some of the design objectives that we had when we were designing our WAF implementation is we had a few pretty odd requirements, I guess you can say. How we source our rules. The tool chain that we ended up having to write, I'll get into in some detail. The testing framework that we're using to make sure that we didn't screw anything up when we wrote our tool chain. Some of the requirements around our testing harness, and then how we're basically integrating this into our CI processes and stuff like that. And finally, probably the more interesting part is what are some of the evasions and vulnerabilities that we found going through this process. So I've been around. So I know a lot of people here. I've been doing security work for roughly 17 years, mainly in Winnipeg, but working all over the place, really. I focus mainly on research and development. We do a lot of research into developing some tools to secure the fleet at Fastly and proof of concept, exploit development, that sort of thing. So a little bit about Fastly. We operate a content delivery network. So we have about 43 POPs. So the way to think about a POP is kind of like a data center, but it's more accurately like a cage with a bunch of racks in co-located data centers around the world. So we're on 6 different continents. Most of our POPs are either on or very close to internet exchanges. We do about around 270 direct peering relationships with various organizations to kind of optimize routing there. Currently, our capacity is we can move about 17.5 terabits a second globally, and we process we can do up to about 30 million requests per second. So you can go on our site and we kind of show what the current loading is. It's usually anywhere from 6 million requests, 7 million requests per second. During election night, I think it shot up to about 11 or 12 million requests per second. So we do things fast, hence the name Fastly. So these on here, these are kind of like where our current POPs are, and then the blue dots are where we're planning on increasing capacity in the future. So a bit about our capabilities. So in addition to being a content delivery network, kind of as a byproduct of how our network is structured, we also do DDoS mitigation. And looking at building kind of like a lot of security technologies into our edge. So the WAF was a big priority for us. But it wasn't as easy as just basically setting up a cluster of like Modsecurity systems and rerouting everything through there. And I'll explain a little bit why we didn't want to do that. So some of our kind of key objectives was the integration with our existing platform. So one of the big things that is really important for us, and I guess for our customers, is kind of the real-time aspect of the service. So if you make a change, it should be reflected globally immediately. We don't want, like, if you're going to go and update like a policy, it have to like roll through all the POPs globally over 6 hours. So having things happen immediately is really important for us. The flexibility. So we support a number of different protocols, so things like IPv6, HTTP2. We want to make sure that things like TLS, we want to make sure that whatever protocol you're using to kind of hit the edge is actually going to be still subject to the web application firewall functionality. And then reduce complexity. So the customer environments are already super complicated. We didn't want to add more bumps in the wire, so to speak. So a lot of customers will have their load balancing, intrusion prevention systems, all this stuff in front of their origin servers, so we didn't want to basically add yet another area where we would have to debug something. So without high quality rules, your WAF implementation is going to suck. I'm sorry, but it's true. So we ended up having to source our rules from a number of different areas. One of the kind of key ones that we use is the OWASP core rule set, and we're currently on version 3. So it's open, you can go and check it out. They actually made a number of really cool improvements between 2. So if you're on 2 right now, I highly recommend that you go and take a look at 3. There's a GitHub link there. We also kind of maintain our own rules, and the reason why we do this is there's just attacks that are kind of specific to content delivery related, like CDN related things. And then if there's certain attacks that we're seeing that are being actively exploited in the wild and we want to rapidly deploy something, then we basically would use our own rules for that. And then we also have a third party, like a private vendor, who's developing stuff for us as well. So all these, if you'll note, are basically use the modsec rule format, and we'll look at what that looks like in a bit. So long story short, we needed a way to basically translate Modsecurity sec rule format into a way that is actually consumable by our platform. And to do that, we ended up engineering a custom toolchain. So this is an example of what a sec rule format looks like. It's pretty straightforward. I mean, you can specify certain collections. So this particular rule is like a chained rule. So it's basically will say, look for this, and it's kind of how Modsecurity accomplishes that. You specify which part of the request really that you want to look for, and then usually you follow up with like some kind of an operator or a pattern that's indicative of an attack. So it's pretty straightforward. So, but this as it wasn't really going to be useful for us. So this is kind of like we are platformed on something called Varnish. We forked it years back, changed the crap out of it. There's no way that anything is really useful would be usable by the open source community unless you're a content delivery network. But it's largely based on something called VCL, which is called the Varnish configuration language. It's basically a domain-specific language that allows our customers to have very granular control over caching policy. So it's kind of reminiscent of C. What happens is this will actually get translated. This will actually get compiled into C, and then basically loaded as basically a shared object. So it's very fast. So when we're writing, so a lot of people think this is very kind of risky, trying to replicate functionality of tools that are already out there. And there's a lot of things that can go wrong, especially since we're using a rule format. So there's a few areas that we're really worried about. And so Modsecurity has something called transforms. So the way to think about a transform is it's a way to kind of normalize the data in a way that you don't have to write a bunch of rules to kind of look for the same attack. So for instance, if you had, there's a to-lower transform, which basically just converts the data to lowercase. If you didn't have that transform, you would need a rule for uppercase and a rule for lowercase as an example. So it's a way to kind of normalize that. But there's all kinds of stuff like, decoding JavaScript, hex encoding, all this kind of stuff, HTML entity encoding, et cetera. So it was really important that we actually did things exactly the same. Collections. So what a collection is if you look at your request data and a post or a get the query string or cookies, there's going to be more than one of them, or headers. So what Modsecurity does is kind of combine this into like a linked list, and then basically the operators will operate on every element of that list. So how collections are parsed is also really important. We wanted to make sure that we didn't screw that up. And then rule chaining and other just kind of like logical constructs. So there's like skip to rules and that kind of stuff in kind of inherent in how Modsecurity works. So if we screwed up anything in here, it would basically result in embarrassing WAF related evasions, and we wanted to avoid those. So testing was absolutely critical for us, that we basically made sure that we got everything right. So the framework that we use is basically written, so it's written in Python. It's called FTW, written by primarily 2 guys, Zach Allen and Chaim, who's also the project lead for the CRS. It was open sourced by Fastly in 2017. The way that it's kind of meant to be used is you can embed it into your own Python code, or you can use like, it works really nicely with the py.test framework as well. But for how we're doing is we're actually just using it as a module. So why a framework? I get this question a lot. Why don't you guys just use shell scripts and curl and all that kind of stuff? So we needed really granular control over the request. The original authors were kind of going for like, kind of like a SCAPI. I don't know if people have kind of played with SCAPI, but a way to kind of like have very granular control over the anatomy of the request itself. And in some cases, we actually want to violate certain aspects of the HTTP protocol. So send requests that would be illegal based on that standard. And a lot of tools wouldn't let us do that. And we also just didn't want to deal with having to have a bunch of clunky shell scripts and parsers and you know, have to like parse request data and all that kind of stuff. And the other big thing is we didn't want to have to necessarily, because we're using CRS, we didn't necessarily want to have to maintain our tests. So using this format, basically the community can maintain some tests for us. So this is kind of the structure. So this was one test that I wrote for rule 941.120. It's pretty basic. So the representation is done in YAML, and this particular test is basically testing this rule is basically looking for SQL operators. And so this is so the other thing is you don't need to be able to write code in order to structure your request. So you just basically need to be able to create this YAML. So the metadata is just kind of that, and then you know we have different stages so that we can actually send multiple requests to move an application into a certain state before we would want to send an attack through. The URI is just basically a really basic test for like a SQL injection, and then so there's other stuff that you can do here. So there's a number of rules. So as a result, there's a lot of tests. You guys can go and check them out. But for us, because of this, there are certain rules that didn't make sense for us because of how basically how the caching engines work. Also, there's tests in there that would be for older versions of a rule that might not fire. So we needed a way to basically say like we needed a way to say like what rule, like which one of these tests are actually broken versus which ones should we expect to work properly. So in order to get our baseline, we ended up writing, we use Chef fairly heavily. So we wrote a cookbook and for the provisioner that will provision Apache Modsecurity and the OWASP CRS with one command basically, and it pulls it up into a Vagrant instance, or like if you want to use like VMware, you could use that too, I guess. So it was really important for us. A harness needed to be configurable. We needed to be able to specify scope. We also, so I just kind of went over that. So the very first objectives, we wanted to make sure that when we were sending an attack through our WAF implementation that it detected and it would drop it. The other kind of really important thing was one attack payload can actually trigger several different rules. So it may be that we're sending an attack payload through that it may have been identified or logged by the WAF, but it may not, the rule that identified the payload might have been some other rule that was completely irrelevant to the attack. So we wanted to make sure that each rule was actually functioning as designed. So a good example is PHP object injection. I think when we were doing tests, I think it fired like 30 different alerts, 30 different signatures that were matched. So in order to do this, we had to basically, we keep a journal, and then we had a custom header that basically has the rule that we're testing for, a timestamp and a test ID, and we send that through to the WAF, and then our WAF actually logs it. And then what we're able to do is basically validate that this attack payload was written for this rule, and this rule actually identified this attack payload, which was important for us. So how do we use this? So everything like we're kind of heavily automated, I guess you could say. So right now, either the SOC or an engineer would, if it wants to create a change to a rule, they would create a branch. They would basically make their change, push their branch. On push, what ends up happening is we run a job which will provision a full instance of our caching engine, compile the rules, load the rules, run through our entire FTW test corpus, and And basically, and then we'll either, conditionally, we can either fail the job if there's like a rule, or we go back and we'll like analyze to see like what the result of the failure was. So this set of tests actually happens on when we push the branch, and then also when we go to merge that branch into master, the job runs again. Probably one thing worth noting is that we had to provision like a special HTTP responder that would basically tell Varnish not to cache any of the data, because we were running into problems where there was certain data that was cached, and then therefore like the WAF code wouldn't run because we weren't actually fetching from origin. The other thing that we do is we look for denial of service attacks in the actual regular expressions themselves, because we're very kind of conscious of CPU use, and we don't want poorly written patterns to actually just waste a bunch of CPU cycles. So I think I kind of talked about that. Right. So we use FTW number ways. So identifying problems in our rules is one thing, but we also kind of use it to verify fixes, and we also use it to identify bugs within our tool chain as well. And then in some cases, like if we found an evasion, we'll actually use the FTW rule format to kind of communicate that upstream. So we found a few things that resulted in evasions, and they're very subtle, so it just will kind of illustrate how easy it is to make a mistake when you're actually writing these rules. So I apologize for the text. I know that it's small, but I actually have the links where we've actually made the pull request to fix it within the OWASP CRS. So this was an example of a chained rule, but the transform was actually happening in the first chain when it needed to be happening in the second chain. So there is a to lower call, and then in the second chain was what actually identified it. So in this case, it was looking for restricted file extensions. So you're able to bypass it with basically using like an uppercase exe instead of a lowercase exe. So again, it was like a two-line fix, but resulted in a pretty simple bypass. This next one was a rule that detects remote file include vulnerabilities, and what it basically does is looking for any instances of like a URL schema within like a post body or a get like variable or a parameter. And so in this, there's actually two problems. There was a scheme that was missing, so file : / was missing. But then also, if you notice on the on what we changed, we actually added, there was also a case insensitive match. So this was another case where you could, if you use like an uppercase HTTP : / in your remote file include attack, you'd basically completely bypass the WAF rules. Let's see how I'm doing for time. Okay, I got 5 minutes. So this one was actually really interesting. So this rule basically detects session fixation, and it did it by basically doing 3 checks. So the first thing it would do is it would actually look for a common instance of a session variable. So PHP session or JSP session or whatever, session variables that would be common in most frameworks. And then what it does is it basically extracts the host name from the HTTP referrer header, and it basically compares it against the actual host header. So in this case, the wrong operator was being used. So it was using begins with instead of when it should have been using ends with. So as you can see in the actual refer, all somebody needed to do to bypass that was actually just prepend the target site to like a subdomain on a domain that they controlled. So again, that was literally a fix of just using ends with instead of begins with. So we also found stuff in our own tool chain. So we were incorrectly sorting and reordering transforms. We are basically applying transforms similar to that last bug, actually applying transforms to incorrect rules in a chain, and just small stupid things like certain lexical parsing of certain related rules and stuff like that. So I also want to send some shout out to 2 of my colleagues from the engineering area who actually found a lot of these problems or were actually tasked with like going through the testing corpus and trying to track down why certain tests were failing. And that's about it. And I'm actually a couple minutes early, so I could probably take a couple questions. If there are any. Yep. Right. So yes. So the question was, we use VCL as on our platform, and as a customer, can I actually run VCL? So yes, you can, and that's actually one of the reasons why a lot of people use us, because it gives them a lot of power over their caching policies.
So to follow up that, security, you have to play a part in VCL, because my understanding is you mentioned
Yeah, so the question was just around the security of the VCL. So this is something that we actually have worked tirelessly to mitigate the risk was. So you can embed C. So in our version, you can't embed C, but we still actually have validators to make sure that that people aren't trying to do that, basically. So, but we have found vulnerabilities where people were able to inject stuff. Luckily, it was us who found it, not somebody bad. But this was a while ago. But there's actually a lot of work kind of going on in terms of like trying to isolate that further. Anyone else? I apologize that there wasn't very many pictures in there, and some. Yeah. 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 So the question is, what size is the team supporting this? So we actually have a security operation center. It's a fairly large team, but it's probably distributed across many groups. So it's like we have a security operations center, we have a security team which is separate from that, and then we also have like the various engineering teams for the various components of it that would be working on it. All right, I think that's it. It's 11:55, so I will get off the stage. Thank you.